settle into the sleepy mind channel. Tonight, we will explore the quiet rhythm of your heart. Across ancient villages, early civilizations, and quiet worlds untouched by electric light, every person who had ever lived carried the same quiet sound inside their chest, a steady pulse moving through darkness beneath skin and bone. Ancient doctors once believed the heartbeat was connected to emotion, spirit, and even the movement of the stars, because the rhythm seemed mysterious and constant at the same time. Long before medical science could explain the heart, people noticed something deeply calming about its regular pattern. Even now, many people fall asleep listening to soft heartbeat sounds because the rhythm feels familiar to the human body itself. At this very moment, your heart is moving blood through nearly every part of your body without asking for attention or rest. It has already beaten thousands of times today alone. By the end of a single lifetime, the number of heartbeats may reach into the billions. Yet most people rarely stop to think about how extraordinary that really is. Hidden inside your chest is a muscular organ working continuously every second of your life, quietly moving warmth, oxygen, nutrients, and energy through a large network of vessels stretching throughout the body, like rivers across a landscape. If you enjoy relaxing sleep stories and calm educational videos like these, feel free to like and subscribe, and check out the playlist filled with fascinating topics designed for long nights of peaceful listening. The human heart is often compared to a pump, and in many ways that comparison is accurate, though the reality is far more elegant than any machine humans have ever created. Mechanical pumps wear down quickly without maintenance, engines overheat, pipes clog. Yet the heart continues working year after year through sleep, movement, stress, quiet moments, and deep rest. Even during sleep, when the conscious mind drifts far from the outside world, the heart continues maintaining circulation through every tissue of the body. The heart itself is made primarily from specialized muscle tissue. Unlike the muscles in your arms or legs, which move only when you decide to lift or walk, the muscle of the heart works automatically. You do not need to remind it to continue beating while reading, speaking, sleeping, or dreaming. Deep inside the body, the muscle contracts and relaxes in a repeating rhythm that begins before birth and normally continues through a lifetime. Few systems inside the body operate with such steady consistency. Although the heart is not especially large, its influence reaches almost everywhere inside the body because circulation connects nearly all biological systems together. Blood carries oxygen gathered from the lungs and delivers it to tissues that constantly require energy to survive. Nutrients absorbed from food move through circulation as well, allowing cells throughout the body to continue functioning. Even heat distribution depends partly upon blood flow, because circulating blood helps move warmth from one region of the body to another. Without circulation, the body would lose this internal movement almost immediately. Oxygen would no longer reach tissues that depend upon it. Waste products would begin accumulating. Organs requiring constant energy would quickly struggle to continue functioning. The steady movement of blood therefore supports nearly every major system inside the body at the same time. The heart maintains this movement continuously through repeated muscular contractions, happening over and over through the night. Many people rarely notice their heartbeat while resting calmly because the rhythm blends into the background of normal life. Yet under certain conditions, such as exercise, fear, excitement, or deep stillness late at night, the pulse suddenly becomes easier to feel. In those moments, people sometimes become aware of the constant rhythm that has been accompanying them every moment since the earliest stages of life. The amount of work performed by the heart over time is astonishing when considered carefully. Blood travels through a large network of arteries, veins, and tiny vessels extending throughout the body. The heart must maintain enough force to keep this circulation moving without interruption. Even while sitting quietly or sleeping peacefully, the system remains active beneath the surface. The body never fully pauses because living tissues constantly require oxygen and nutrients delivered through circulation. Humans have studied the heart for thousands of years because its importance seemed obvious long before science fully understood circulation itself. Ancient civilizations sometimes believed the heart was the center of thought, memory, courage, or emotion. While modern science later discovered that the brain controls conscious thought, the emotional connection people feel toward the heartbeat never completely disappeared. Rapid heartbeats often accompany fear or excitement, while slow, steady rhythms are associated with calmness and rest. The heart also reflects something larger about the human body itself. Beneath awareness, countless biological systems work continuously to maintain balance and survival. Breathing continues automatically. Cells repair themselves quietly. Blood moves through vessels without pause. The body is filled with processes unfolding silently in the background, while daily life continues above them. The heartbeat may be one of the clearest examples of this hidden biological rhythm, because its movement can sometimes be felt directly beneath the chest or within the pulse of the wrist. At rest, the heart often beats regularly, maintaining a rhythm steady enough that people throughout history compared it to music, drums, tides, or clocks. Yet unlike mechanical systems, the heartbeat remains alive and responsive. It changes during movement, sleep, stress, excitement, illness, and relaxation, while still preserving the continuous circulation required for survival. The rhythm adapts constantly while maintaining stability at the same time. Deep inside the chest tonight, your own heart continues this ancient quiet rhythm without pause. Muscle contracts. Blood moves forward. Oxygen travels through vessels. Warmth circulates through tissues. Life continues through repeated cycles, happening silently beneath awareness. Long before humans understood circulation, the heartbeat was already moving through living bodies across the world, steady and continuous beneath the quiet darkness of sleep itself. The human heart rarely beats randomly. Instead, it follows a repeating pattern so dependable that doctors, scientists, and musicians have often compared it to rhythm in music. During quiet rest, the heartbeat usually settles into a steady pace that gently repeats again and again through the night. This regular timing allows blood to continue moving smoothly throughout the body without interruption. Although people often think of the heartbeat as a single event, the reality is more like an ongoing sequence of carefully timed movements unfolding continuously beneath the chest. Perhaps while lying awake late at night, after climbing stairs, during exercise, or during moments of excitement or fear. Yet even when unnoticed, the rhythm continues working constantly beneath awareness. The body depends on this steady pattern because circulation only functions properly when blood keeps moving through vessels at a reliable pace. If the rhythm became completely chaotic, circulation would quickly lose stability, and tissues throughout the body would struggle to receive consistent oxygen and nutrients. Inside the body, rhythm serves a practical purpose far beyond calmness alone. The regular timing of the heartbeat allows blood flow to remain smooth rather than uneven or disorganized. Each beat pushes blood forward through vessels, while the brief space between beats allows the heart to prepare for the next movement. The cycle repeats with consistency. Even during sleep, when awareness fades, the rhythm quietly continues beneath the surface. The heart must maintain this steady flow because the body constantly depends upon circulation. Oxygen moves from the lungs into the bloodstream and then travels outward toward tissues requiring energy to survive. Nutrients absorbed during digestion also move through circulation, so cells throughout the body can continue functioning properly. Waste products travel away through the same moving system. Without steady blood flow, this immense transportation network would begin failing almost immediately. The body contains a large network of vessels extending through nearly every region from the scalp to the fingertips to the smallest tissues deep within organs. The heart must continue maintaining movement through this entire network day after day, year after year. Rhythm makes this possible because steady, repeated contractions create reliable forward movement rather than sudden, irregular bursts of pressure. At rest, however, the heartbeat often settles into an especially regular rhythm designed to support quiet stability inside the body. During sleep or deep relaxation, many systems inside the body begin conserving energy. Breathing may become slower and steadier. Muscles relax. Yet even in these restful conditions, circulation never completely pauses because living tissues continue requiring oxygen and nutrients every moment. The heartbeat therefore remains active throughout the night, maintaining movement quietly beneath the calm stillness of sleep. Doctors today often study rhythm carefully because regular patterns reveal important information about how effectively the heart is functioning. A stable repeating rhythm generally reflects coordinated electrical activity and organized blood flow inside the body. Even the familiar sound heard through a stethoscope reflects this repeating sequence of muscular movement and valve activity unfolding inside the chest. The sounds themselves arise from motion, pressure, and timing working together in precise coordination. The idea of rhythm also appears throughout nature beyond the human body. Ocean tides rise and fall in repeating cycles. Seasons return year after year. Daylight shifts gradually into darkness every evening. Human sleep itself follows repeating cycles during the night. Nature often relies upon rhythm because repeating organized patterns create stability within living systems. The heartbeat may be one of the most personal examples of this larger principle because its rhythm accompanies every moment of human life. The rate may increase dramatically during running or physical effort, yet the body still relies upon organized timing to maintain effective circulation. The rhythm adapts while preserving order. This flexibility allows the heart to respond to changing conditions without losing the coordinated movement required for survival. The body depends upon this repeating process so completely that people rarely stop to think about how extraordinary it truly is. Every quiet beat inside the chest contributes to the movement of blood through an immense living network supporting nearly every organ and tissue. The rhythm continues while people work, speak, sleep, dream, exercise, rest, or sit quietly listening during the night. Beneath all conscious activity, the heartbeat remains steady and continuous. Deep inside the chest tonight, your own heart continues this repeating rhythm with calm consistency. Blood moves forward through vessels. Oxygen travels outward toward tissues requiring energy. Warmth circulates throughout the body. The pulse repeats again and again steadily beneath the quiet darkness of rest itself. Although the heartbeat may sound simple from the outside, the interior of the heart contains a carefully organized arrangement designed to keep blood moving in specific directions throughout the body. Deep inside the chest, the heart is divided into 4 separate chambers, working together in coordinated sequence. These chambers do not all perform the same task at the same time. Instead, each section participates in a repeating flow pattern, allowing blood to move steadily through the lungs, back into the heart, and then outward again toward the rest of the body. The upper portion of the heart contains 2 smaller chambers whose primary role is receiving blood, returning through circulation. Beneath them sit 2 larger muscular chambers responsible for pumping blood outward with greater force. This layered arrangement allows the heart to manage incoming and outgoing blood movement continuously without creating complete disorder inside the organ itself. The structure may appear complicated at first glance, yet the organization supports one clear goal: continuous forward circulation. Airports separate arriving passengers from departing travelers. Highways use lanes moving in different directions. Water systems rely upon organized pathways guiding movement through pipes and channels. Inside the heart, a somewhat similar principle exists because blood must travel through specific chambers in a carefully coordinated sequence to maintain effective circulation. The 2 upper receiving chambers are known as atria. Their role is to collect blood returning toward the heart through veins. One side receives blood coming back from the body after oxygen has already been delivered to tissues. The other side receives blood returning from the lungs carrying fresh oxygen. These chambers act almost like quiet collection areas where blood gathers briefly before moving deeper into the stronger pumping chambers below. Beneath the atria sit the ventricles, the larger and more muscular lower chambers responsible for pushing blood outward with substantial force. One ventricle pumps blood toward the lungs, while the other pumps blood outward toward nearly the entire body. The muscular walls of these lower chambers are thicker because pushing blood through long networks of vessels requires significant pressure and strength. In particular, the left ventricle must generate enough force to move blood through circulation, reaching from the brain to the fingertips to the feet. This arrangement creates organized flow rather than chaotic movement inside the heart. Blood enters receiving chambers first before moving downward into pumping chambers. From there, it exits through major vessels, continuing circulation throughout the body and lungs. The process repeats continuously through coordinated timing and muscular movement, occurring with every heartbeat. The heart itself fits comfortably inside the chest, yet inside this relatively small organ exists a complete circulation management system operating without pause throughout life. Every chamber participates in carefully timed movement, allowing blood to travel enormous distances throughout the body over time. The simplicity of the repeating cycle hides the extraordinary precision required to maintain continuous circulation through the night. The separation between the chambers also serves an important purpose because different regions of the heart handle blood moving toward different destinations. One side manages blood traveling toward the lungs where oxygen exchange occurs. The other side manages oxygen-rich blood preparing to move outward throughout the body. Keeping these flows organized allows circulation to remain efficient and stable rather than mixing randomly inside the heart. Even the muscular walls separating sections of the heart contribute to this organization by maintaining boundaries between chambers while supporting coordinated contraction. The entire organ behaves less like a hollow bag and more like a carefully arranged muscular system where structure and timing work together continuously. Every beat depends not only on strength, but also on organized internal movement following specific pathways. Humans studying anatomy for centuries were fascinated by this internal design because the heart seemed both simple and incredibly sophisticated at the same time. Ancient physicians understood that the heart moved blood long before circulation itself was fully explained scientifically. Later discoveries gradually revealed the organized chamber system hidden inside the organ and the specific directional pathways blood follows during each cycle. The heart also demonstrates how biological systems often rely upon compartmental organization to perform complex tasks efficiently. The lungs contain branching air passages, guiding airflow toward tiny exchange surfaces. The brain contains specialized regions supporting different functions. The digestive system moves material through organized stages. Inside the heart, the four-chamber arrangement creates orderly circulation through repeated coordinated movement. Every heartbeat depends upon this organization remaining reliable. Blood enters receiving chambers, moves downward into pumping chambers, and then exits through vessels leading either toward the lungs or toward the rest of the body. The pattern repeats continuously through every hour of life. Even during deep sleep, when awareness fades almost completely, the chambers continue coordinating movement quietly beneath the surface. At rest, this flow pattern often unfolds with remarkable smoothness and consistency. Blood returns through veins, chambers fill, muscular contraction pushes blood forward, pressure changes guide movement through the system. The sequence repeats again and again beneath awareness from the person carrying this living circulation network inside their chest. Deep inside the body tonight, your own heart continues this organized movement without interruption. Upper chambers receive returning blood, while lower chambers push blood outward once again. Flow follows carefully arranged pathways through the organ, with each repeating beat. Within the quiet darkness beneath the chest, four chambers continue maintaining circulation through one of the most carefully organized systems inside the body. Inside the heart, blood must continue moving forward in an organized direction if circulation is going to remain stable and efficient. The four chambers create pathways for flow, yet another important system works quietly alongside them to guide movement precisely. These are the valves of the heart. Thin but durable flaps of tissue positioned between chambers and major vessels that open and close repeatedly throughout every heartbeat. Their task is simple in principle, but absolutely essential in function. They help keep blood moving forward while preventing large amounts from flowing backward. Humans have long relied upon one-way systems in everyday life, even without thinking much about them. Water pumps often contain valves preventing liquid from reversing direction inside pipes. Air systems use flaps or gates, controlling movement through enclosed passages. Even simple doors inside buildings organize movement by guiding people through particular spaces. Inside the heart, valves perform a somewhat similar role because circulation depends upon organized forward movement rather than random shifting of blood between chambers. The opening and closing of heart valves does not usually require control or separate muscular effort from the person carrying the heart inside their chest. Instead, the valves respond automatically to changing pressure conditions created by the heartbeat itself. As chambers fill and contract, pressure rises or falls within different regions of the heart. These pressure changes gently push the valves open or closed at the correct moments within the cycle. When pressure behind a valve becomes greater than pressure ahead of it, the valve opens and allows blood to continue moving forward. When pressure reverses, the valve closes, helping reduce backward flow. This process repeats continuously throughout every heartbeat. The movement is quick, automatic, and remarkably coordinated with the larger rhythm of circulation unfolding inside the chest. People never consciously feel the opening or closing of their heart valves, even though these structures may move billions of times across many decades of life. Yet the sound doctors hear through a stethoscope partly reflects these movements because the familiar heartbeat sounds arise largely from valves closing during different stages of circulation. Without organized valve function, circulation would lose much of its efficiency because blood could move backward more easily during each cycle. The heart would then need to work harder to maintain forward movement throughout the body. By helping guide flow in organized directions, the valves support smoother circulation and reduce unnecessary energy loss inside the system. The structure of the heart therefore reflects careful biological organization rather than random arrangement. Chambers receive and pump blood in sequence. Valves guide movement between regions. Pressure changes coordinate opening and closing. Muscular contractions generate force at the correct moments. Everything inside the organ contributes toward one continuous goal: maintaining reliable circulation throughout the body. The body depends upon this organization because blood must travel through a large network of vessels extending nearly everywhere inside the body. Oxygen-rich blood needs to reach tissues requiring energy, while oxygen-poor blood must return toward the lungs for renewal. The heart manages this movement continuously through coordinated structure and timing unfolding beneath awareness. Another reason biological systems often appear elegant is because structure and function are deeply connected. The shape of bones supports movement. The branching form of lungs supports airflow. Blood vessels divide into smaller pathways, allowing circulation to reach tiny tissues throughout the body. Inside the heart, valves demonstrate this same relationship because their placement and movement support efficient forward blood flow during every cycle. The opening and closing of valves also contributes to the rhythm people associate with the heartbeat itself. Each beat is not merely a single muscular squeeze, but rather a carefully timed sequence involving chambers, filling, contracting, and directing blood through organized pathways. The sounds heard during a heartbeat reflect this coordinated movement unfolding repeatedly inside the chest. At rest, the entire process usually occurs with extraordinary consistency. Blood enters receiving chambers, pressure shifts, valves open briefly, blood moves downward into stronger pumping chambers. Contraction increases pressure again. Valves close while other pathways open, allowing blood to move outward into circulation. The sequence repeats precisely from one beat to the next. Scientists and doctors studying the heart often admire how much work the organ performs, using relatively simple physical principles repeated continuously over time. Pressure differences guide flow. Valves respond automatically. Chambers contract in sequence. Blood follows organized pathways through vessels. Yet from these repeating patterns emerges one of the most essential systems supporting human life itself. Even during quiet sleep, when the outside world becomes distant and still, this internal movement continues beneath the chest without pause. Valves continue opening and closing. Pressure rises and falls inside the chambers. Blood keeps moving forward through vessels reaching throughout the body. The rhythm remains steady while circulation quietly supports warmth, oxygen delivery, nutrient movement, and many biological processes continuing through the night. Deep inside your chest tonight, this organized system continues its quiet work. Valves guide movement through the heart with each repeating cycle. Pressure changes direct blood forward while helping prevent large backward movement. Chambers, vessels, rhythm, and structure all operate together within one carefully arranged biological system, maintaining circulation beneath the calm darkness of rest itself. The movement of blood through the heart does not happen randomly or all at once. Instead, circulation follows a repeating cycle, unfolding continuously with every heartbeat. Inside the chest, the heart moves through alternating phases of contraction and relaxation that work together to maintain steady blood flow throughout the body. One phase pushes blood outward through vessels, while the next allows chambers to refill before the process begins again. The cycle repeats continuously from the earlier stages of life onward, often without a person ever consciously noticing the immense activity happening beneath the surface. Many natural systems depend upon repeating cycles rather than constant uninterrupted force. Ocean tides rise and fall. Breathing alternates between inhaling and exhaling. Daylight gradually shifts into darkness before morning returns once again. Even walking relies upon alternating movements, repeated over and over in organized sequence. The heart follows this same principle because circulation depends not only on muscular strength, but also on timing and recovery between contractions. When the heart contracts, muscular walls tighten around blood contained inside the chambers. This contraction increases pressure within the heart and pushes blood forward into major vessels, leading either toward the lungs or outward throughout the body. The movement may sound simple when described in words, yet the coordination required is extraordinary because different chambers contract at carefully timed moments within the larger rhythm of circulation. The phase of contraction is often compared to squeezing water through a tube or pressing liquid through connected pipes. Pressure rises inside the heart and blood moves toward areas of lower pressure ahead. Valves help guide this movement while preventing large amounts of backward flow. Every contraction therefore contributes to maintaining continuous circulation through a large network of vessels stretching nearly everywhere inside the body. Yet contraction alone would not sustain circulation for long, because the chambers also require time to refill with blood before the next beat can occur effectively. This is where relaxation becomes equally important. After contraction, the muscular walls loosen and pressure inside certain chambers falls. Blood returning through veins then flows into the heart once again, gradually filling the chambers in preparation for the next cycle. Relaxation may sound passive compared to contraction, yet it is an essential part of the heartbeat, because the heart cannot continue pushing blood forward unless it first receives enough blood to pump. The alternating pattern of squeezing and filling creates a repeating rhythm, supporting steady organized flow through the circulation system. One movement prepares for the next in continuous sequence. The body depends on this repeating cycle because tissues throughout the body constantly require oxygen and nutrients delivered through blood flow. The brain, muscles, lungs, kidneys, skin, and countless other tissues all rely upon circulation remaining active every moment. Even while sleeping quietly during the night, living cells continue requiring energy and oxygen carried through vessels by the movement generated inside the heart. The heart does not stop completely between beats. Instead, the phases blend together in repeating sequence consistently. Chambers fill while others contract. Pressure changes guide flow through valves and vessels. Blood moves continuously, even though the heart itself alternates between active pushing and recovery phases. Doctors and scientists often study these cycles carefully because the timing and coordination of contraction and relaxation reveal important information about heart function. Modern medical imaging can show chambers filling and emptying in real time, while electrical activity coordinates the movement beneath the surface. Yet long before advanced technology existed, people could still recognize the pulse created by these repeating cycles simply by placing fingers against an artery. The cycle itself also reflects the efficiency found throughout many biological systems. Muscles require periods of relaxation after contraction. Breathing alternates between inhaling and exhaling. Sleep itself balances activity and recovery across the body and brain. The heart follows a similar principle because continuous circulation depends upon repeated organized cycles rather than constant muscular tightening. At rest, the heartbeat often becomes slower and steadier because the body requires less immediate oxygen delivery compared to intense physical activity. The cycle continues calmly beneath the chest while blood moves through vessels carrying warmth and nutrients throughout the body. During exercise or excitement, the same cycle accelerates while preserving its organized sequence. The heart adapts its pace without abandoning the repeating pattern required for stable circulation. A notable detail about this process is how many times it repeats throughout a lifetime. Beat after beat, day after day, year after year, the heart continues alternating between contraction and relaxation reliably. Most people rarely pause to consider how extraordinary this truly is, because the movement happens automatically beneath awareness from the beginning of life onward. Even during deep sleep, when conscious thought drifts far from the outside world, the cardiac cycle continues quietly inside the chest. Chambers contract and blood moves forward. Chambers relax and refill once again. Pressure rises and falls in repeating patterns supporting circulation through every region of the body. The sequence continues without pause through darkness, dreams, movement, stillness, and rest. Deep inside your chest tonight, this continuous cycle remains active beneath awareness. Muscular walls tighten and release in organized rhythm. Blood moves forward through vessels, while chambers prepare for the next beat. Contraction and relaxation repeat again and again steadily, maintaining the quiet movement of circulation through the sleeping body itself. Every heartbeat depends not only on strength, but also on coordination. Inside the heart, different chambers, valves, and muscular movements must operate in carefully timed sequence if circulation is going to remain smooth and reliable. A heartbeat that arrived too early, too late, or completely out of order would reduce the efficiency of blood flow throughout the body. The heart therefore relies upon remarkable timing to maintain the repeating rhythm supporting circulation throughout life. Traffic lights organize movement through busy intersections, so vehicles continue flowing safely rather than colliding in confusion. Orchestra musicians follow shared timing, so individual sounds combine into recognizable music instead of noise. Even walking requires careful coordination because muscles must activate in organized sequence to maintain balance and movement. Inside the chest, the heart follows a similarly organized pattern, where timing allows many separate movements to function together as one continuous process. The chambers of the heart do not all contract at the exact same instant. The upper receiving chambers move first, helping direct blood downward into the larger pumping chambers below. Shortly afterward, the stronger lower chambers contract and push blood outward toward the lungs and body. This sequence allows circulation to remain organized rather than chaotic. If every chamber contracted simultaneously without coordination, blood flow would become far less effective. Valves also participate in this carefully timed system. They open and close according to pressure changes created during different stages of the heartbeat. As one chamber fills, another may be contracting. As pressure rises in one region, valves respond by opening or closing at the appropriate moment. Everything inside the heart depends upon organized timing, unfolding repeatedly with each cycle. During rest, movement, sleep, or emotional excitement, the heart continuously adjusts its pace while preserving the overall sequence required for effective circulation. The rhythm may become faster during physical activity or slower during deep relaxation, yet the internal coordination still remains essential no matter how quickly or slowly the heart is beating. The consistency of the heartbeat allows blood flow to remain steady throughout the body rather than arriving in unpredictable bursts. Tissues throughout the body depend upon relatively continuous circulation because cells require ongoing oxygen and nutrient delivery every moment. The brain in particular relies heavily upon stable blood flow, since nerve tissue requires enormous amounts of energy compared to many other tissues inside the body. The pulse people feel in arteries reflects this organized coordination unfolding inside the chest. Each pulse wave, moving through vessels, begins with carefully timed contraction inside the heart itself. Beneath the surface of the skin, the repeating rhythm reveals the continuity of circulation, traveling throughout the body regularly. Scientists studying the cardiovascular system often describe the heartbeat as both electrical and mechanical at the same time. Electrical signals coordinate timing, while muscular contraction creates movement and pressure. The two systems work together continuously, allowing the heart to maintain rhythm across enormous stretches of time without conscious direction from the person carrying it inside their chest. The continuity of circulation is one of the most astonishing parts of human biology. Most muscles throughout the body eventually rest after periods of activity. Arms relax after lifting objects. Legs stop moving during sleep. Yet the heart continues cycling through contraction and relaxation continuously from before birth until the end of life. Even while a person sleeps deeply through the night, the process never truly pauses because blood flow must continue supporting living tissues every second. Another reason the heartbeat often feels calming to people is because consistent rhythm creates a sense of biological stability. Humans are naturally sensitive to repeating patterns. A steady pulse can feel reassuring because it reflects organized internal function continuing reliably beneath awareness. Many forms of relaxation music and sleep sound recordings imitate repeating rhythms for this very reason. The nervous system often responds positively to calm, predictable timing. Inside the body, however, the rhythm serves far more than emotional comfort alone. Every coordinated cycle maintains circulation through arteries, veins, and tiny capillaries spread across nearly every tissue. Oxygen moves towards cells requiring energy. Carbon dioxide and waste products move away. Heat circulates throughout the body. Hormones and nutrients travel through the bloodstream toward distant organs and tissues. All of this movement depends upon the continuity maintained by the repeating cardiac cycle. The timing of the heartbeat also demonstrates how deeply organized biological systems truly are. Beneath awareness, countless microscopic events unfold with extraordinary coordination. Electrical signals spread through tissue. Muscle fibers shorten and relax. Valves respond to changing pressure. Blood shifts through chambers and vessels. None of this usually requires deliberate thought or control from the person resting quietly above the process itself. At night, during calm stillness and sleep, the rhythm often becomes especially noticeable because the outside world grows quieter. A person lying awake in darkness may sometimes become aware of the gentle pulse within inside the chest or neck. In those moments, it becomes easier to sense the continuity of the process, quietly supporting life beneath the surface of conscious thought. Deep inside your chest tonight, timing and coordination continue precisely. Chambers contract in organized sequence, while valves guide movement forward through the heart. Rhythm maintains steady circulation throughout the body, while blood continues flowing quietly through vessels beneath the calm darkness of rest itself. For much of human history, people believed the heartbeat was controlled directly by emotion, spirit, or conscious will, because the rhythm seemed both mysterious and deeply personal. Fear could suddenly make the heart race. Calmness could slow the pulse noticeably. Yet as science gradually uncovered the inner workings of the body, researchers discovered something remarkable hidden deep within the heart itself. The heartbeat is guided by electrical signals generated inside the organ. Tiny waves of electrical activity spread through specialized tissue and quietly coordinate every contraction occurring within the chambers of the heart. When many people hear the word electricity, they imagine bright sparks, machines, or powerful currents moving through wires. The electrical system of the heart is far quieter and more delicate, yet it remains one of the extraordinary biological systems inside the body. Tiny electrical impulses move through heart tissue in carefully organized patterns, guiding muscular contraction precisely. Without these signals, the chambers would struggle to contract in proper sequence, and circulation would quickly lose stability. A useful detail in the heart is that the signals controlling the heartbeat originate inside the heart itself, rather than beginning consciously within the mind. Specialized groups of cells, hidden within the upper region of the heart, generate repeating electrical impulses automatically. These cells act almost like a natural biological timing system, producing regular signals that help establish the rhythm of the heartbeat through the night. The existence of these specialized cells explains why the heart can continue beating automatically without requiring conscious effort. You do not need to remember to activate each heartbeat while sleeping, reading, walking, or dreaming, because the electrical system inside the heart continues generating impulses on its own. Even during deep sleep, when awareness of the outside world fades almost completely, these cells remain active inside the chest, maintaining the repeating rhythm of circulation. Once generated, the electrical signal begins spreading outward through heart tissue. The wave of electrical activity travels along organized pathways, allowing different regions of the heart to contract in proper sequence. The upper chambers respond first, before the signal moves downward toward the larger pumping chambers below. This organized spread of activity allows blood to continue moving efficiently through the heart and outward into circulation. The relationship between electricity and muscle movement exists throughout much of the body. Nerves use electrical activity to communicate with muscles, allowing arms, legs, and facial muscles to move. Inside the heart, however, the electrical system is especially important because coordination must continue continuously without pause throughout life. Every heartbeat depends upon electrical activity and muscular contraction working together in repeating sequence. A notable detail about the heart is how quickly these electrical signals move through tissue. The entire sequence unfolds in fractions of a second, yet the process repeats reliably through the night. People never consciously feel the electrical impulses themselves, even though every heartbeat depends upon their organized movement inside the chest. Doctors and scientists often study this electrical activity carefully because it reveals important information about heart function and rhythm. Electrocardiograms, commonly known as ECG recordings, measure tiny electrical changes occurring during the heartbeat. The repeating patterns visible on these recordings reflect electrical signals spreading through heart tissue and coordinating contraction. Long before modern imaging allowed doctors to see the inside of the heart clearly, electrical recordings already revealed the hidden rhythm guiding circulation beneath the surface. The coordination created by these signals allows the chambers of the heart to function together rather than independently. Upper chambers contract first, while lower chambers prepare to pump blood outward moments later. Valves respond to changing pressure as blood moves forward through organized pathways. The entire system depends upon electrical timing, guiding muscular movement throughout the cycle. Even emotional experiences can influence this electrical system indirectly. Fear, excitement, stress, exercise, relaxation, and sleep all affect signals reaching the heart from the nervous system. The rhythm may become faster or slower depending on the body's needs at that moment. Yet beneath these changes, the internal electrical system continues preserving organized coordination within the heartbeat itself. Scientists often describe the heart as both an electrical organ and a muscular organ at the same time, because the two functions are inseparable. Electrical signals guide movement while muscle tissue creates force and pressure. Together, they maintain the continuous flow of blood, supporting nearly every tissue throughout the body. At night, during stillness and rest, this hidden electrical activity continues quietly inside the chest without drawing attention to itself. Tiny impulses emerge from specialized cells and spread through tissue in repeating patterns. Chambers contract in sequence while blood continues moving through vessels beneath the calm darkness of sleep. Deep inside your chest tonight, invisible electrical signals continue guiding each heartbeat precisely. Specialized cells generate repeating impulses while waves of activity spread through the heart in organized sequence. Muscle contracts, blood moves forward. Rhythm continues quietly beneath awareness, maintaining the steady circulation, supporting the sleeping body itself. Inside the heart, timing is everything. The chambers must contract in the proper order, valves must respond at the correct moment, and electrical signals must move through tissue in carefully organized sequence if circulation is going to remain smooth and effective. A heartbeat is not simply a random muscular squeeze happening inside the chest. It is a coordinated event, guided by precise timing, unfolding repeatedly throughout life. The remarkable stability of circulation depends upon this invisible sequence continuing reliably beneath awareness. Electrical activity inside the heart acts almost like a conductor guiding musicians through a complex performance. In an orchestra, instruments must enter at the correct moment, or the entire piece loses structure and harmony. Inside the heart, electrical signals guide different regions of tissue, so contraction occurs in organized sequence rather than confusion. The upper chambers respond first, helping blood move downward, before the stronger lower chambers contract and push blood outward into circulation. The speed at which these electrical signals travel is carefully regulated, because even small changes in timing can influence how effectively blood moves through the heart. Signals spread through specialized pathways inside the organ, allowing activity to reach different chambers at the appropriate moments within each cycle. This timing ensures that filling and pumping occur in the correct order again and again through the night. Specialized cells within the heart continue generating electrical impulses automatically in repeating patterns, creating the rhythm underlying circulation itself. Even during quiet sleep, when the outside world becomes distant and still, these signals continue moving through heart tissue steadily. Beat after beat, the process repeats continuously beneath awareness. Unlike many systems humans build, however, the heart does not require constant conscious supervision in order to continue functioning. The control system responsible for generating electrical signals exists largely within the heart itself. Specialized cells continue producing impulses automatically, while pathways inside the tissue guide activity through the chambers. This self-regulating design allows circulation to continue during sleep, unconsciousness, quiet rest, and ordinary daily activity without requiring deliberate thought. The internal nature of this control system is one of the most remarkable features of the heart. Many muscles inside the body depend heavily upon conscious direction from the brain. Arms move when you choose to lift them. Legs move when you decide to walk. The heart, however, contains specialized tissue capable of generating and coordinating its own rhythmic electrical activity automatically. This internal regulation allows the heartbeat to continue continuously throughout life. The nervous system still influences the heart by adjusting rate and response according to changing conditions. Fear may increase the heartbeat. Relaxation may slow it. Exercise may cause rhythm to accelerate, while sleep often allows the pulse to settle into a calmer pace. Yet beneath these changing conditions, the internal electrical system continues preserving the organized sequence required for effective circulation. The heartbeat continues independently without control, yet it also responds continuously to the needs of the body. Faster rhythms support physical activity, while slower rhythms conserve energy during rest. The underlying timing system therefore remains stable, while still adjusting to changing conditions through the night. The repeating nature of electrical activity inside the heart also creates consistency within circulation itself. Blood continues moving through vessels in organized waves rather than chaotic surges. Oxygen delivery remains stable across tissues, requiring continuous energy. Pressure rises and falls in repeating patterns, supporting flow throughout the body. The rhythm established by electrical timing becomes the foundation beneath the entire circulation system. Most people rarely think about electrical activity while feeling their pulse or listening to their heartbeat. Yet hidden beneath the chest, countless tiny electrical events coordinate muscular movement precisely throughout life. The process continues so reliably that it usually disappears into the background of awareness entirely. Doctors and researchers continue studying these electrical systems carefully because they reveal so much about heart health and biological coordination. Tiny disruptions in timing may alter rhythm or circulation efficiency. Modern technology can measure electrical patterns directly, revealing the hidden waves of activity moving through tissue beneath the surface of the body. At night, during deep rest and quiet stillness, this internal coordination becomes almost poetic in its consistency. Electrical signals emerge from specialized cells. Activity spreads through pathways inside the heart. Chambers contract in sequence, while blood continues moving steadily through vessels. The cycle repeats continuously with little attention from the person sleeping peacefully above it. Deep inside your chest tonight, the heart continues regulating itself through invisible waves of electrical activity moving in organized sequence. Signals repeat steadily, while muscular chambers respond with coordinated movement. Timing guides flow. Rhythm maintains circulation. The quiet electrical system within the heart continues its steady work beneath the calm darkness of rest itself. Although the heartbeat often feels steady and predictable, the rate of the heart is constantly adjusting to the needs of the body. The rhythm does not remain fixed at exactly the same pace every moment of the day, because the demands placed upon circulation change continuously during movement, rest, emotion, sleep, and physical activity. The heart therefore behaves less like a rigid mechanical clock and more like a responsive living system, capable of adapting its pace while still preserving organized rhythm and steady blood flow. Climbing stairs may cause the pulse to quicken noticeably. Fear or surprise can suddenly create a pounding heartbeat inside the chest. After exercise, the rhythm often remains elevated for a short time before gradually slowing again during recovery. Late at night, while resting quietly in bed, the heartbeat may become slower and calmer than it was earlier during a busy active day. Movement increases the body's demand for oxygen and energy. Muscles working harder require more fuel delivered through circulation. Breathing becomes deeper, while the heart responds by increasing its rate, allowing blood to move more rapidly through vessels toward tissues requiring support. During intense physical activity, this adjustment can become dramatic as circulation accelerates to keep pace with the changing needs of the body. Rest creates very different conditions inside the body. During calm relaxation or sleep, muscles use less energy compared to periods of intense activity. Breathing often slows. Many systems begin conserving energy while the body recovers from the demands of the day. Under these quieter conditions, the heartbeat commonly becomes slower and steadier because circulation no longer needs to move at the same rapid pace required during movement or stress. Most people do not consciously decide to increase or decrease their heartbeat during exercise, fear, or rest. Instead, the body constantly monitors conditions and adjusts circulation through signals involving the nervous system, hormones, and internal regulation within the heart itself. The process unfolds quietly beneath awareness, while the body responds continuously to changing needs. The nervous system plays an important role in these adjustments because signals traveling through nerves help influence the pace of the heartbeat. During stress or excitement, certain signals encourage the heart to beat faster and with greater force. During calmness and relaxation, different signals support slower, steadier rhythms associated with rest and recovery. The body therefore maintains a continuous conversation between the brain, nervous system, and heart through the night. Even emotional experiences can strongly influence heart rate because the body often responds to feelings with physical changes. Excitement may create rapid pulses. Anxiety can produce pounding heartbeats. Relief and calmness may allow the rhythm to settle once again. Humans noticed this connection long before modern science understood the biological systems involved, because emotional experiences frequently become visible through changes in pulse and heartbeat. The ability of the heart to adjust its rate while preserving coordination is one of the most impressive features of circulation. Faster rhythms during exercise still require organized electrical timing and controlled contraction within the chambers. Slower rhythms during sleep must still maintain enough circulation to support living tissues continuously. Doctors often study heart rate carefully because changes in pulse provide important information about how the body is responding to different conditions. Athletes who train regularly may develop slower resting heart rates because their hearts become highly efficient at moving blood. Illness, stress, fever, dehydration, and many other conditions can influence pulse as well. The heartbeat therefore reflects not only activity within the heart itself, but also the larger state of the body. During deep rest, the body often shifts into a calmer biological state, where the pulse becomes slower and more regular. Muscles relax, breathing steadies, energy demands decrease. Yet even in these peaceful conditions, the heart never fully stops its work because circulation must continue supporting the brain, lungs, organs, and tissues throughout the night. The flexibility of the heartbeat reflects the adaptability of life itself. Living systems constantly respond to changing conditions rather than remaining completely fixed. Temperature changes influence the body. Movement changes oxygen demand. Emotions alter nervous system activity. Sleep changes energy requirements. Through all of these shifting circumstances, the heart quietly adjusts its pace to help maintain balance inside the body. Deep inside your chest tonight, your own heartbeat continues responding automatically to the quiet needs of the resting body. Electrical signals guide rhythm, while circulation moves steadily through vessels beneath the skin. During calm stillness, the pulse often softens into a slower, more peaceful rhythm, maintaining circulation quietly beneath the darkness of sleep itself. The body is constantly changing from one moment to the next. Temperature shifts slightly throughout the day. Muscles alternate between activity and rest. Emotions influence breathing, circulation, and tension within the body. Even quiet changes in posture, such as standing, sitting, or lying down, alter how blood moves through vessels. Because conditions never remain perfectly still for long, the heart must continuously respond and adjust in order to maintain balance within the circulation system. Signals moving throughout the body help the heart respond to these changing conditions with remarkable speed and precision. The nervous system constantly gathers information about oxygen demand, blood pressure, movement, temperature, and many other internal conditions. Messages then travel through nerves and chemical pathways, helping regulate the heartbeat according to what the body requires at that moment. The process usually happens so smoothly that most people never notice the constant adjustments quietly unfolding beneath awareness. When a person stands suddenly after resting, gravity influences how blood shifts inside vessels. The body responds rapidly by adjusting circulation to help maintain steady blood flow toward the brain. During exercise, muscles require additional oxygen and nutrients, so the heartbeat accelerates, while vessels in active tissues may widen to support greater flow. During sleep, energy demands decrease and the rhythm often slows. These adjustments occur automatically through communication between the nervous system, blood vessels, hormones, and the heart itself. Tiny differences in oxygen levels, pressure, or carbon dioxide concentration may influence signals affecting circulation. Receptors within blood vessels and organs constantly monitor these conditions and help guide the body's responses. Beneath awareness, enormous amounts of information move continuously through biological systems, maintaining internal stability. The heart, therefore, behaves less like an isolated organ and more like part of a much larger communication network extending throughout the body. Signals from the brain influence circulation. Signals from blood vessels influence pressure regulation. Signals from active muscles influence heart rate and blood flow. Every part of the system remains connected through ongoing exchange of information and response. Regulation is especially important because tissues throughout the body depend upon relatively stable circulation despite changing conditions outside and inside the body. The brain requires continuous oxygen delivery, whether a person is walking, sleeping, reading, or exercising. Muscles require more circulation during movement, but less during rest. Skin blood flow changes partly in response to temperature. The heart must help support all of these shifting demands while preserving overall balance within the circulation system. Even emotional experiences influence this regulation because feelings often trigger physical responses throughout the body. Fear may increase pulse and blood pressure rapidly. Calmness may soften breathing and slow the heartbeat. Anticipation, stress, relief, and excitement all influence signals moving through the nervous system. Humans have sensed this connection for thousands of years because emotional experiences frequently become visible through changes in circulation and pulse. A notable feature of the cardiovascular system is how quickly it can adapt while remaining coordinated. The body does not stop circulation in order to make adjustments. Instead, changes unfold continuously while blood keeps moving through vessels without interruption. The heartbeat shifts pace smoothly. Blood vessels widen or narrow subtly. Pressure changes gradually. The system adapts while maintaining ongoing flow throughout the body. Scientists studying circulation often describe this process as regulation through feedback. The body constantly monitors internal conditions and responds when adjustments become necessary. If pressure drops too low, signals may encourage stronger circulation. If tissues require additional oxygen, the heart may increase its pace. These responses help preserve stability despite changing conditions throughout daily life. At night, during quiet rest, many of these regulatory systems continue working gently beneath awareness. Breathing slows, muscles relax. The heartbeat often settles into calmer rhythms, supporting recovery and conservation of energy. Yet even in deep sleep, the body remains active internally because circulation, oxygen delivery, temperature regulation, and many biological processes continue throughout the night. The adaptability of the heart reflects something larger about life itself. Living systems survive not because conditions remain perfectly constant, but because they can respond to change while preserving balance. The heartbeat adjusts to movement, stress, rest, temperature, emotion, and sleep without losing the coordinated rhythm required for circulation. Through continuous adaptation, the body maintains stability across constantly changing conditions. Deep inside your chest tonight, this quiet regulation continues automatically beneath awareness. Signals move through nerves and tissue, while the heartbeat responds gently to the needs of the resting body. Pressure adjusts. Rhythm adapts. Circulation remains steady, while blood continues flowing through vessels beneath the calm darkness of sleep itself. The heart may generate the force-moving blood throughout the body, but circulation itself depends upon a large network of vessels extending through nearly every tissue from the top of the head to the smallest regions inside organs. These vessels form an intricate transportation system, carrying oxygen, nutrients, warmth, hormones, and many other substances throughout the body, throughout life. Hidden beneath the skin is a branching network so extensive that if all the vessels inside the body were placed end to end, the distance would stretch astonishingly far across the landscape. Blood does not simply move through one single type of vessel. Instead, circulation relies upon several connected systems working together continuously. Arteries carry blood away from the heart under pressure generated by muscular contraction. Veins return blood back toward the heart after circulation through tissues. Between these larger pathways lies a vast network of tiny vessels known as capillaries, where exchange with body tissues takes place. Together, these vessels create a complete circulation loop, supporting nearly every biological process inside the body. Arteries are built to handle the strong pressure created when the heart contracts and pushes blood outward. Their walls contain layers of elastic and muscular tissue, allowing them to expand slightly with each pulse before relaxing again. This elasticity helps smooth blood flow as pressure waves move through circulation following every heartbeat. Large arteries near the heart branch repeatedly into smaller vessels, traveling toward organs, muscles, skin, and deeper tissues throughout the body. Many people become aware of arteries through the pulse felt at the wrist or neck. Each pulse reflects pressure waves moving outward through arterial walls after contraction inside the heart. Even though the heartbeat occurs deep within inside the chest, the force travels through vessels extending throughout the body. In quiet moments late at night, some people can even feel the gentle rhythm within fingertips, temples, or beneath the jaw. Veins perform a different but equally important role by carrying blood back toward the heart after circulation through tissues. Compared to arteries, veins usually experience lower pressure because much of the force generated by the heartbeat has already diminished after blood travels through smaller vessels and organs. Veins therefore rely upon several helpful mechanisms to support return flow, including one-way valves inside many vessels and the movement of surrounding muscles during ordinary activity. The journey through circulation resembles rivers branching outward from a central source before eventually returning through connected channels once again. Blood leaves the heart through major arteries, travels into smaller vessels reaching tissues throughout the body, and later returns through veins, completing the cycle. The entire system remains connected continuously, allowing circulation to move without pause through large networks hidden beneath the surface of the body. Between arteries and veins lies one fascinating part of circulation itself: the capillaries. These vessels are extraordinarily small and delicate compared to larger arteries and veins. In many places, capillary walls are only a single cell thick, creating extremely short distances between blood and surrounding tissues. This thinness allows important exchange processes to occur efficiently throughout the body. Capillaries form vast microscopic networks extending through muscles, organs, skin, and nearly every living tissue. Blood flowing through these tiny vessels slows considerably compared to movement inside large arteries. This slower movement creates time for oxygen and nutrients to leave the bloodstream and enter nearby cells, while waste products move in the opposite direction back towards circulation. Most tissues remain only tiny distances away from nearby capillary networks. Oxygen carried through blood can therefore move efficiently into cells requiring energy, while carbon dioxide and waste products move outward towards circulation for removal. Life at the cellular level depends upon this quiet, ongoing exchange occurring continuously inside microscopic vessels. Major highways branch into smaller roads, leading toward neighborhoods and individual homes. Water systems divide from large pipes into narrower lines, reaching buildings throughout cities. Inside the body, circulation follows a similar pattern, because large vessels branch repeatedly into smaller networks capable of reaching tiny tissues throughout the body. The organization of blood vessels also reflects efficiency and adaptation within biological systems. Tissues requiring large amounts of oxygen, such as muscles or the brain, contain especially rich capillary networks supporting continuous energy demand. Even skin contains extensive circulation, helping regulate temperature and deliver nutrients to surface tissues. The body distributes blood carefully according to the needs of different organs and regions. At rest, blood continues moving steadily through this entire vessel network beneath awareness. Arteries carry blood outward from the heart. Veins guide returning flow back once again. Capillaries quietly support exchange between circulation and living tissues. Most people rarely think about this hidden movement because the system operates so reliably in ordinary life. During sleep, the circulation system continues functioning consistently despite the stillness of the resting body. Blood moves through vessels reaching the brain, lungs, muscles, organs, and skin throughout the night. Oxygen delivery continues. Nutrients circulate quietly through tissues. Waste products move back toward removal systems. Beneath the calm surface of sleep, the vast vessel network remains active every moment. Deep inside your body tonight, blood continues flowing through arteries, veins, and tiny capillary networks extending through nearly every tissue. Pressure waves move outward from the heart, while returning circulation flows quietly back once again. Within microscopic vessels, oxygen and nutrients pass gently into living cells beneath the quiet darkness of rest itself. Deep inside the body, a major exchange in human biology is happening constantly and quietly throughout life. Oxygen carried through the bloodstream moves out from tiny capillaries into nearby tissues, while waste products created by living cells move back into circulation for removal. Most people rarely notice this process directly because it unfolds on a microscopic scale beneath awareness. Yet nearly every organ and tissue inside the body depends upon this continuous movement in order to survive. Oxygen is essential because cells require it to release energy from nutrients and continue functioning properly. Every thought, movement, heartbeat, breath, and biological process depends ultimately upon energy production occurring inside cells throughout the body. Without sufficient oxygen delivery, tissues begin struggling almost immediately because many cellular activities cannot continue normally for long periods in its absence. The lungs help bring oxygen into the body through breathing, but circulation is what delivers that oxygen outward toward distant tissues. Blood acts almost like a transportation system carrying oxygen through vessels extending across enormous biological distances inside the body. The heart generates movement, while arteries and capillaries guide oxygen-rich blood toward organs, muscles, skin, and countless smaller tissues requiring continuous support. Capillaries are especially important during this stage because their extremely thin walls allow oxygen to move from blood into nearby cells efficiently. The process happens through natural differences in concentration rather than mechanical force. Oxygen tends to move from areas where it is more abundant toward areas where it is needed inside tissues. Across the tiny distances separating blood from cells, this quiet movement continues constantly through the night. At the same time, waste products created during cellular activity begin moving in the opposite direction. As cells use oxygen and nutrients to release energy, they also generate substances that must eventually be removed from tissues. Carbon dioxide is a major example because it forms naturally during many energy-producing processes inside cells. If waste products accumulated continuously without removal, normal biological function would quickly become disrupted. Circulation therefore performs two connected tasks at once. It delivers oxygen and nutrients toward tissues while also carrying waste products away. Blood flowing through capillaries acts almost like a moving exchange system, supporting many microscopic transfers throughout the body every second. The process may be invisible to awareness, yet life depends upon its continuity. The lungs gather oxygen through breathing. The digestive system absorbs nutrients from food. The heart generates movement and pressure. Blood vessels distribute materials throughout tissues. The kidneys later help remove certain waste products from circulation. No single system operates entirely alone because biological function depends upon ongoing cooperation between many connected organs and tissues. The body itself is often described as an integrated system for precisely this reason. Muscles depend upon oxygen delivery from circulation. The brain depends upon stable blood flow for energy. Skin depends upon circulation for warmth and repair. Organs exchange information and materials through the bloodstream continuously. Even emotions and stress responses influence circulation through signals involving the nervous system and hormones. Flow supports all of these functions because movement allows resources to travel between distant regions of the body. Without circulation, oxygen gathered by the lungs would never reach muscles or organs requiring energy. Nutrients absorbed from food would remain trapped within the digestive system. Waste products would accumulate instead of being carried toward removal systems. Circulation, therefore, acts almost like the connecting movement linking many separate biological processes into one coordinated whole. Scientists often marvel at how efficiently this exchange system operates. Blood moves continuously through enormous vessel networks, while tiny capillaries provide access to individual tissues throughout the body. Oxygen enters cells, while waste products leave almost simultaneously. The process repeats constantly without control from the person resting quietly above it. Oxygen flows from blood into tissues throughout the brain, muscles, lungs, skin, and organs. Carbon dioxide and other waste products move quietly back into circulation. The heartbeat maintains pressure, while blood vessels guide movement throughout the body. Beneath the calm darkness of rest, the exchange supporting life continues without interruption. A useful detail in circulation is how dynamic the process remains at all times. Blood flow may increase toward active muscles during movement or exercise. During sleep, circulation patterns shift according to changing energy demands across different tissues. The body continuously adjusts flow according to need while preserving the steady movement required for oxygen delivery and waste removal. Most people rarely consider how much quiet activity is unfolding inside their body during an ordinary moment of rest. Trillions of cells continue requiring oxygen and generating waste products every second. Capillaries continue supporting exchange throughout tissues. Blood keeps moving through vessels, while the heart maintains circulation beneath awareness. Deep inside your body tonight, oxygen continues moving gently from blood into living tissues requiring energy. Waste products flow quietly back into circulation for removal. The heart maintains movement, while vessels connect organs and tissues throughout the body. Beneath the stillness of sleep, circulation continues supporting life through endless quiet exchange beneath the darkness of rest itself. Blood does not move throughout the body simply because vessels exist. Movement requires force, and inside the circulation system that force is created largely through pressure generated by the heart itself. Every heartbeat produces changing pressure conditions inside chambers and vessels that help guide blood forward throughout the body. Without these pressure differences, circulation would quickly slow and eventually stop because blood, like many fluids in nature, tends to move from areas of higher pressure toward areas where pressure is lower. Humans encounter the effects of pressure constantly in ordinary life, even if the principle often goes unnoticed. Water flows through pipes because pressure pushes it along connected pathways. Air rushes outward when a balloon is released because pressure inside exceeds the surrounding atmosphere. Wind itself develops partly through pressure differences in the atmosphere across large regions of the planet. Inside the body, circulation follows similar physical principles because blood moves according to pressure gradients created and maintained by the heartbeat. When the muscular walls of the heart contract, pressure inside the chambers rises sharply. This increase in pressure pushes blood forward into major arteries leading away from the heart. The movement resembles squeezing liquid through connected tubing, where force generated in one area drives flow toward regions of lower resistance farther ahead in the system. Every contraction therefore contributes to maintaining circulation throughout the body. The stronger lower chambers of the heart generate especially important pressure because they are responsible for pushing blood through extensive vessel networks. The left ventricle in particular must create enough force to move oxygen-rich blood through arteries reaching nearly every tissue from the brain to the fingertips to the feet. The muscular walls of this chamber are noticeably thicker because circulation throughout the body requires substantial pressure and endurance over long periods of time. Blood naturally moves from areas where pressure is relatively high toward areas where pressure is lower. This principle helps guide circulation through vessels continuously during each heartbeat. After the heart contracts and pressure rises within the chambers, blood moves outward into arteries where pressure is slightly lower ahead. As blood travels farther through circulation, pressure gradually decreases across smaller vessels and capillaries before returning toward the heart through veins. A useful detail in circulation is how pressure changes continuously throughout the system rather than remaining uniform everywhere at once. Arteries near the heart experience stronger pressure waves generated during contraction. Smaller vessels farther away experience gentler flow conditions. Veins returning blood toward the heart usually contain much lower pressure because much of the original force has gradually diminished throughout circulation. The pulse people feel at the wrist or neck reflects these pressure waves traveling through arteries after each heartbeat. Every pulse represents the movement of force outward through elastic vessel walls following contraction inside the heart. Even though blood itself flows continuously rather than in isolated bursts, the repeating pressure waves remain detectable beneath the skin. Blood vessels are not rigid pipes completely unchanged by circulation. Arterial walls contain elastic tissue, allowing them to expand slightly as pressure rises during contraction and relax again afterward. This elasticity helps smooth movement throughout the system and reduces sudden extremes in pressure during each cycle. In many ways, the flexibility of vessels supports more stable circulation throughout the body. Veins respond differently because pressure within them is generally lower compared to arteries. Many veins contain one-way valves, helping guide blood back toward the heart, while surrounding muscles assist movement during walking and ordinary activity. The entire vessel system therefore responds continuously to changing pressure conditions generated by the heartbeat itself. Scientists studying circulation often describe pressure as one of the central forces underlying blood movement throughout the body. Without pressure differences, Oxygen and nutrients could not travel effectively through vessels toward tissues requiring energy. Waste products would not move efficiently back toward removal systems. The entire circulation network depends upon pressure gradients maintained through repeated contraction of the heart. Most people rarely think about pressure while resting quietly or sleeping peacefully at night, yet circulation depends upon these invisible forces unfolding continuously inside the body. Every beat changes pressure conditions slightly inside chambers and vessels, maintaining movement through the large network hidden beneath the skin. The relationship between pressure and circulation also demonstrates how deeply physics and biology connect within living systems. The heart is biological tissue composed of living muscle, yet the movement of blood follows physical principles involving pressure, resistance, elasticity, and flow. Nature often combines biology and physics together in elegant ways throughout the body. During exercise or physical effort, the heart increases its force and rate, partly because active muscles require greater circulation and oxygen delivery. During quiet rest or sleep, pressure and rhythm often settle into calmer patterns, while still maintaining enough movement to support the body continuously through the night. Deep inside your chest tonight, muscular contraction continues creating pressure that quietly moves blood throughout the body. Arteries expand gently with each pulse, while blood flows from areas of higher pressure toward regions where pressure is lower ahead. Beneath the calm darkness of rest, invisible forces continue guiding circulation through vessels reaching nearly every living tissue within the sleeping body itself. The circulation system depends not only on the force generated by the heart, but also on the design of the blood vessels carrying blood throughout the body. Every artery, vein, and capillary contributes to maintaining stable movement through carefully shaped structures adapted for specific roles inside circulation. Vessel walls are not identical everywhere because different regions of the system experience different pressures, flow conditions, and biological demands. Together, these specialized structures help maintain balance while guiding blood through a large network reaching nearly every tissue inside the body. Arteries closest to the heart experience the strongest pressure created during contraction. Their walls therefore contain thick layers of elastic and muscular tissue capable of stretching slightly when blood surges forward during each heartbeat. This elasticity is extremely important because it helps smooth pressure changes rather than allowing circulation to move only in sudden violent bursts. As arteries expand and relax gently with each pulse, blood flow becomes steadier throughout the system. As arteries branch into smaller vessels farther from the heart, pressure gradually decreases across the circulation network. Smaller arteries and related vessels help regulate flow toward different tissues by changing diameter slightly according to the needs of the body. Some vessels widen, allowing increased blood movement into active regions, while others narrow gently when less flow is required. This ongoing adjustment helps maintain balance throughout circulation despite constantly changing conditions. Pressure regulation is a major task within the cardiovascular system because blood must continue moving efficiently without overwhelming delicate tissues. If pressure became excessively low, circulation might struggle to deliver oxygen effectively throughout the body. If pressure became excessively high for long periods, vessel walls and organs could experience increasing strain. The body therefore relies upon multiple systems working together continuously to maintain relatively stable circulation. The nervous system contributes to this regulation by influencing both heart activity and vessel behavior. Hormones also participate by affecting vessel diameter, fluid balance, and circulation under different conditions. Even the kidneys help regulate pressure indirectly through their influence on fluid and chemical balance inside the body. Circulation therefore depends upon coordination between many biological systems rather than the heart acting entirely alone. Blood travels because pressure differs between one region and another, creating directional movement through vessels. The same principle appears throughout nature. Rivers flow downhill because elevation differences create movement. Air shifts across the atmosphere because pressure varies between regions. Inside the body, circulation depends upon gradients guiding blood from areas of relatively higher pressure toward areas where pressure is lower ahead. The branching structure of vessels also supports controlled movement throughout the body. Large arteries leaving the heart divide repeatedly into smaller pathways capable of reaching individual organs, muscles, and tissues. Eventually, circulation enters microscopic capillary networks where oxygen and nutrient exchange occur. Blood then begins the return journey through small veins, gradually merging into larger vessels, carrying circulation back toward the heart once again. Veins differ from arteries because they usually experience lower pressure after blood has already traveled through capillary networks and tissues. Their walls are generally thinner and less muscular compared to major arteries. Many veins contain internal valves, helping guide blood back toward the heart while reducing backward movement. Muscle contractions during ordinary movement also help support venous return by gently squeezing surrounding vessels. Balance within circulation changes constantly according to the body's needs. During exercise, vessels supplying active muscles may widen significantly to support increased oxygen delivery. During cold conditions, circulation near the skin may decrease partly to preserve warmth deeper inside the body. During sleep, many systems shift toward calmer patterns associated with recovery and reduced energy demand. The cardiovascular system adapts continuously while preserving overall stability. Trillions of cells depend upon oxygen and nutrient delivery every moment, yet the body usually maintains stable movement through vessels without conscious effort from the person resting quietly above the process itself. The entire system operates through ongoing adjustment and balance rather than rigid, fixed conditions. At night, while the outside world becomes quiet and still, blood continues moving through this carefully regulated network beneath the skin. Pressure changes gently with each heartbeat, while vessels respond continuously to maintain stable flow. Oxygen travels toward tissues requiring energy, while waste products move back through circulation. Beneath the calm darkness of sleep, balance remains active throughout the body. Deep inside your body tonight, arteries, veins, and tiny vessels continue guiding blood through carefully regulated pathways. Pressure gradients maintain movement, while vessel walls respond gently to changing conditions. Flow remains controlled through one of the most sophisticated transportation systems found anywhere in the natural world, continuing quietly beneath the stillness of rest itself. For thousands of years, long before modern medical instruments existed, people learned that important information about the body could be discovered simply by feeling the pulse. Ancient physicians would place fingers gently against the wrist, neck, or other arteries, and quietly observe the repeating rhythm beneath the skin. Without seeing the heart directly, they understood that this movement reflected something deeper happening inside the chest. Even today, the pulse remains one of the clearest and most familiar signs of circulation, quietly continuing throughout the body. The pulse itself is not the direct movement of the heart touching distant parts of the body. Instead, it reflects waves of pressure traveling outward through arteries after each heartbeat. When the heart contracts, blood is pushed into the arterial system with force. Arterial walls respond by expanding slightly as the pressure wave moves through them. This gentle expansion can often be felt beneath the skin in places where arteries travel close to the surface. Most people cannot directly feel blood moving through tiny capillaries or deep vessels inside the body, yet the pulse allows the rhythm of circulation to become detectable through touch alone. A quiet repeating movement beneath the fingertips reveals the ongoing activity of the heart, hidden deeper inside the chest. The arteries themselves play an important role in creating the pulse sensation because their elastic walls expand and relax with changing pressure during each heartbeat. If arteries were completely rigid, circulation would behave very differently, and the familiar pulse would not feel the same beneath the skin. The flexibility of vessel walls allows pressure waves to travel smoothly through circulation while creating the gentle rhythmic movement people recognize as the pulse. The original movement begins in one place, yet the effect travels outward across connected space. In circulation, the contraction of the heart generates pressure that moves outward through vessels, creating repeating waves detectable far from the chest itself. Every pulse at the wrist therefore reflects activity beginning inside the heart moments earlier. The rhythm of the pulse can reveal a surprising amount about conditions inside the body. A calm resting pulse often feels slower and steadier during quiet relaxation or sleep. Physical activity may create faster, stronger pulses as circulation increases to support active muscles. Fear, excitement, stress, illness, and many other conditions can influence the rhythm as well. Long before modern monitoring devices existed, physicians recognized that pulse patterns often reflected changes occurring throughout the body. At rest, many people notice the pulse only faintly because circulation usually remains calm and steady during relaxation. Yet during exercise or emotional excitement, the pulse may become much more obvious beneath the skin as the heart increases force and rate. In quiet stillness late at night, some people become newly aware of their pulse because the outside world grows so silent that internal rhythms become easier to notice. The pulse also demonstrates how circulation creates repeating patterns throughout the body. Every heartbeat sends another wave of pressure outward through arteries. The sequence repeats continuously through the night consistently. Even while sleeping peacefully, pressure waves continue moving through vessels beneath the skin, maintaining circulation throughout the body. Doctors today still study the pulse carefully because it provides useful information about heart rate, rhythm, circulation strength, and blood vessel behavior. Modern technology can measure circulation precisely, yet the simple act of feeling a pulse remains one of the oldest and most direct ways humans connect with the rhythm of the living body. Every person carries this quiet rhythm continuously throughout life. Before birth, circulation already begins developing inside the growing body. Through childhood, adulthood, sleep, movement, stress, and aging, the pulse continues reflecting the steady movement of blood through vessels beneath the skin. Few biological rhythms accompany human life as constantly as the heartbeat itself. The pulse also reflects the relationship between pressure and vessel structure throughout circulation. Arteries closest to the heart usually produce stronger pulse sensations because pressure remains higher near the source of contraction. Farther away in tiny capillaries, the pressure waves become much softer and less noticeable as circulation transitions towards slower exchange processes within tissues. Scientists studying blood flow often describe circulation as both dynamic and patterned at the same time. Pressure rises and falls. Vessels expand and relax. Blood moves continuously through changing pathways while still preserving organized rhythm across the entire system. The pulse reveals this hidden movement through a simple repeating sensation beneath the fingertips. At night, during calm rest, the pulse often softens into a slower, steadier rhythm, reflecting the quieter demands of the sleeping body. Breathing slows, muscles relax, yet circulation continues beneath the surface consistently. Pressure waves move gently through arteries, while blood carries oxygen and warmth throughout the body during sleep. Deep inside your body tonight, the heartbeat continues sending waves of pressure outward through vessels beneath the skin. Arteries expand gently with each pulse, while circulation maintains its repeating rhythm throughout the body. Beneath the calm darkness of rest, the quiet patterns of blood flow continue moving steadily through the sleeping body itself. The body is filled with patterns quietly repeating beneath awareness. Breathing rises and falls in cycles. Sleep moves through changing stages during the night. Hormones increase and decrease according to daily rhythms linked to light and darkness. The heartbeat belongs to this larger world of biological patterns because circulation depends upon organized repeating movement rather than randomness or disorder. Every pulse, every contraction, and every pressure wave reflects carefully coordinated rhythms supporting life inside the body. Another reason doctors and scientists pay close attention to heartbeat patterns is because changes in rhythm often reveal information about the condition of the body itself. A calm resting pulse may reflect relaxation or recovery. Faster rhythms may appear during physical effort, emotional stress, illness, or excitement. Even subtle changes in timing can sometimes reveal how the body is responding to internal or external conditions. The heartbeat, therefore, acts almost like a continuous biological signal, carrying information about the state of circulation and overall activity inside the body. Humans have sensed this connection for thousands of years. Ancient physicians often relied heavily upon pulse observation because they recognized that heartbeat patterns seemed connected to health, emotion, strength, exhaustion, and illness. Without modern instruments, they still understood that the rhythm beneath the skin reflected hidden activity unfolding inside the body. Even today, the pulse remains one of the most immediate ways to observe circulation directly. Physical activity creates some of the clearest changes in heartbeat patterns. During exercise, muscles require additional oxygen and nutrients in order to continue working efficiently. The body responds by increasing circulation through faster heart rate and stronger blood movement. The pulse becomes more rapid and noticeable as pressure waves travel through arteries beneath the skin. Once activity ends and the body begins recovering, the rhythm usually slows gradually toward calmer resting patterns again. Emotional experiences can also influence heartbeat patterns because the nervous system responds strongly to fear, excitement, stress, anticipation, and calmness. Sudden surprise may create a racing pulse. Anxiety can produce pounding sensations inside the chest. Quiet relaxation often allows the heartbeat to soften into slower, steadier rhythms. Humans frequently describe emotional experiences using the language of the heart precisely because these physical changes are so easy to feel. Yet despite these adjustments, the heartbeat usually remains highly organized beneath the changing pace. Faster rhythms during exercise still rely upon coordinated electrical timing and controlled contraction. Slower rhythms during sleep still preserve steady circulation throughout the body. The adaptability of the heart depends upon maintaining organization, even while conditions change continuously through the night. Biological systems must adapt to changing demands without losing coordination. The heart accomplishes this through repeating electrical signals, organized contraction, responsive blood vessels, and ongoing communication with the nervous system. Together, these systems allow circulation to remain both dynamic and reliable at the same time. The repeating patterns of circulation extend far beyond the pulse alone. Pressure rises and falls with each heartbeat. Blood vessels expand and relax. Oxygen moves continuously into tissues, while waste products return toward removal systems. Flow changes according to movement, temperature, sleep, stress, and countless other conditions. Beneath awareness, the body remains filled with rhythmic biological activity, supporting life every moment. Every person carries a slightly unique rhythm influenced by age, health, activity, emotion, sleep, and countless other biological factors. Some people naturally have slower resting pulses while others beat somewhat faster. Athletes may develop highly efficient circulation patterns through long periods of physical training. Yet despite these differences, the underlying organization of circulation remains remarkably consistent across human life. The pulse also demonstrates how information travels through physical movement inside the body. A simple touch against the wrist can reveal changing heart rate, rhythm regularity, and circulation strength without directly seeing the heart itself. Long before advanced medical imaging existed, humans already understood that patterns within the pulse reflected hidden processes unfolding deep inside the chest. At night, during quiet rest, heartbeat patterns often become calmer and steadier because the body shifts toward recovery and reduced energy demand. Breathing slows, muscles relax. Many systems conserve energy while circulation continues supporting tissues throughout the body. In these quieter moments, the pulse may feel especially rhythmic and peaceful beneath the skin. Another reason rhythmic sounds and repeating patterns often help people fall asleep may be connected partly to this deep biological familiarity. Human beings spend an entire lifetime accompanied by internal rhythms. Breathing repeats. The heartbeat continues steadily beneath the chest. Blood moves in organized waves through vessels. Calm, repeating patterns may feel reassuring because they mirror processes already present quietly inside the body. Even during sleep, however, circulation never becomes completely motionless. The heartbeat continues sending pressure waves through arteries, while blood carries oxygen and warmth toward tissues throughout the body. Patterns shift gently, according to changing stages of rest and recovery during the night. Beneath stillness, movement continues. Deep inside your body tonight, the heartbeat maintains its organized rhythm beneath the quiet darkness of rest. Pressure waves travel through arteries, while circulation follows repeating patterns throughout the sleeping body. The pulse reflects the quiet activity of life itself, continuing steadily beneath awareness through the calm stillness of the night. The heart spends throughout life working continuously, yet many people rarely stop to consider something fascinating about this muscular organ. The heart itself also depends upon circulation in order to survive. Although it pumps blood throughout the body, the heart muscle still requires its own supply of oxygen and nutrients to continue functioning properly. Like every other living tissue, the cells inside the heart need constant energy support because continuous movement over long periods demands enormous biological effort. The amount of work performed by the heart across a lifetime is astonishing when considered carefully. Day and night, year after year, muscular tissue contracts and relaxes repeatedly without pause. Even during deep sleep, when arms and legs rest quietly beneath blankets, the heart continues generating pressure and maintaining circulation throughout the body. Few mechanical systems created by humans could continue operating continuously for decades with such consistency and endurance. Muscle activity always requires energy, and the heart is no exception. Every contraction depends upon microscopic processes occurring inside muscle cells, where oxygen and nutrients help release the energy needed for movement. Without continuous oxygen delivery, heart muscle would quickly lose its ability to maintain strong, coordinated contractions. The heartbeat therefore depends not only on electrical signals and muscular structure, but also on constant biological support from circulation itself. Blood flowing outward from the heart eventually returns, carrying oxygen and nutrients capable of supporting the heart muscle itself. Specialized blood vessels branch from major arteries near the heart and spread across the surface of the organ, delivering circulation directly into the muscular tissue responsible for pumping blood. These vessels are known as coronary arteries, and they form an intricate network supplying oxygen-rich blood to the heart muscle. Without this circulation, the muscular walls of the heart would struggle to continue generating the force required for each beat. The heart therefore depends upon its own circulation system while simultaneously supporting circulation throughout the rest of the body. The heart pumps blood through vessels, yet the heart itself relies upon those same vessels for survival. Oxygen delivery supports contraction, while contraction maintains oxygen delivery. The system forms a continuous loop where each part depends upon the others functioning properly at the same time. The heart muscle is especially demanding because of its constant activity. Muscles in the arms or legs may rest for long periods between movement, but the heart rarely experiences complete relaxation in the ordinary sense. Even between beats, the organ continues preparing for the next cycle. The energy requirements of this tissue remain high because circulation must continue without interruption throughout life. Oxygen plays a central role in supporting this activity because muscle cells use oxygen during energy production processes occurring continuously inside the tissue. Nutrients carried through blood also contribute to maintaining cellular function within the heart muscle itself. The bloodstream therefore acts as both transportation system and energy supply network, supporting the organ responsible for circulation. Scientists often describe the heart as remarkably efficient because it performs such enormous work while remaining relatively compact inside the chest. The coordination between electrical timing, muscular contraction, vessel elasticity, pressure regulation, and oxygen delivery allows the organ to continue functioning across immense stretches of time. Yet despite this efficiency, the heart still depends upon stable circulation and oxygen supply to maintain its activity. The relationship between circulation and the heart muscle also demonstrates how living systems depend heavily upon feedback and support rather than isolated function. No organ operates entirely alone. The lungs provide oxygen entering the bloodstream. Blood vessels distribute circulation. The digestive system absorbs nutrients. The nervous system influences heart rate and pressure. The kidneys help regulate fluid balance. Every major system contributes in some way toward maintaining the conditions required for the heartbeat to continue. At rest, the heart often works somewhat more slowly because the body's immediate oxygen demands decrease during relaxation and sleep. Yet even in these calmer states, the organ continues requiring its own steady blood supply. Coronary vessels continue delivering oxygen-rich blood into the muscle tissue, while contraction and relaxation repeat continuously throughout the night. Cells repair themselves. Hormones shift according to internal rhythms. Breathing supports oxygen exchange in the lungs. Circulation continues carrying nutrients and removing waste products throughout the body. Deep inside the chest, the heart continues working steadily, while also receiving the oxygen and energy support it needs to sustain that work. Humans throughout history often viewed the heart as a symbol of endurance because its activity accompanies throughout life. From the earliest heartbeat before birth until the final moments of life, the organ continues its repeating rhythm beneath awareness. The constant movement of circulation depends upon the health and energy of this muscular tissue hidden inside the chest. Deep inside your body tonight, the heart continues its quiet work beneath the calm darkness of sleep. Oxygen-rich blood flows through vessels, supplying the heart muscle itself, while contraction and relaxation maintain circulation throughout the body. The organ that supports every tissue also depends upon the same movement it creates, continuing its endless rhythm through the stillness of the night itself. One of the most remarkable truths about the human body is that no major system works completely alone. The heartbeat may feel like a separate rhythm hidden inside the chest, yet circulation depends upon constant cooperation between many connected biological systems working together throughout life. Breathing supplies oxygen, blood vessels distribute circulation, muscles use energy, the nervous system regulates timing and response, hormones influence pressure and flow. Even sleep changes the demands placed upon circulation throughout the body. Beneath the surface of awareness, the body functions through ongoing coordination between countless interconnected processes. Energy lies at the center of this cooperation because nearly every biological activity requires it in some form. Cells throughout the body depend upon oxygen and nutrients carried through circulation in order to continue functioning. Muscles require energy for movement. Nerve cells require energy for communication. Organs require energy for repair, regulation, and chemical activity. The circulation system acts almost like a transportation network, supporting all of these processes simultaneously by moving resources throughout the body. The heart itself depends upon this shared support as well. Oxygen-rich blood supplied through coronary vessels nourishes the heart muscle, while the organ continues pumping blood outward through circulation. The lungs gather oxygen through breathing. Blood carries that oxygen through vessels. The heart maintains movement through the system. Every stage depends upon another stage functioning properly at the same time. Cities depend upon electricity, transportation, water systems, communication networks, and food delivery operating together continuously. If one major system fails completely, many others begin struggling as well because modern infrastructure is deeply interconnected. Inside the body, the same principle exists in biological form because organs and tissues constantly exchange resources, signals, and support through circulation and communication networks. A useful detail in human biology is how efficiently these systems usually operate despite the enormous complexity involved. The body regulates pressure, oxygen delivery, temperature, fluid balance, and energy use continuously without requiring conscious attention from the person resting quietly above the process. Countless adjustments unfold every second beneath awareness, while the body maintains remarkable internal stability across changing conditions. Circulation supports this efficiency because movement allows distant regions of the body to remain connected. Oxygen gathered in the lungs reaches muscles and organs through blood flow. Nutrients absorbed during digestion travel through vessels toward tissues requiring energy. Waste products move back toward organs responsible for removal. Hormones released from glands travel through circulation, carrying chemical messages throughout the body. The bloodstream therefore acts not only as transportation, but also as communication between different biological systems. Activity inside the body never completely stops, even during quiet sleep. Breathing continues steadily throughout the night. Blood vessels regulate flow and pressure. Cells repair damage accumulated during the day. The brain remains active through changing sleep stages. Hormones rise and fall according to internal rhythms linked to darkness and light. Beneath the stillness of the sleeping body, biological activity continues continuously. The heart reflects this constant activity, perhaps more clearly than any other organ, because its movement remains easy to feel through pulse and heartbeat. Yet beneath the familiar rhythm lies enormous hidden complexity involving electrical signals, muscular contraction, vessel elasticity, oxygen exchange, energy production, and pressure regulation unfolding together in coordinated sequence. Scientists often describe living systems as dynamic rather than static, because the body maintains balance through constant movement and adjustment instead of remaining perfectly still. Circulation changes according to activity, temperature, stress, posture, and sleep. Breathing changes according to oxygen demand. Hormones shift according to time of day and environmental conditions. The body survives not through immobility, but through organized adaptation and continuous cooperation between systems. Long before humans existed, early organisms were already developing ways to transport nutrients, regulate energy use, and maintain internal balance. Over immense stretches of time, circulation systems became more specialized and efficient, eventually supporting the complex organs and large active bodies found in modern animals. The interconnected nature of the body also explains why physical and emotional conditions often influence many systems at once. Stress may change breathing, pulse, muscle tension, digestion, and sleep simultaneously. Relaxation may soften heartbeat, breathing, and blood pressure together. The body responds as a connected whole rather than isolated independent parts functioning separately. At night, during calm rest, many systems shift toward recovery and conservation while still remaining active beneath the surface. The heartbeat often slows into steadier rhythms. Muscles relax. Breathing becomes quieter. Yet circulation continues carrying oxygen and nutrients throughout the body, while countless cells remain busy sustaining life through ongoing microscopic activity. Most people rarely consider how extraordinary this quiet cooperation truly is. Trillions of cells continue functioning together beneath the skin, while organs exchange resources and information through circulation continuously. Every heartbeat supports countless biological events unfolding simultaneously throughout the body. Deep inside your body tonight, circulation continues linking organs, tissues, nerves, vessels, lungs, and muscles together through constant movement beneath the calm darkness of sleep. Oxygen flows through blood, while energy supports living cells throughout the body. Beneath stillness, the interconnected systems of the human body continue their quiet work through the endless rhythm of circulation itself. By now, the hidden rhythm inside the chest begins to feel less like a simple heartbeat and more like an immense living system built from movement, timing, pressure, and coordination, all working together continuously. The heart does not operate through strength alone. Rhythm guides contraction. Electrical signals organize timing. Pressure moves blood through vessels. Valves direct flow. Oxygen travels toward tissues, while waste products return through circulation. Beneath awareness, many biological processes cooperate together through one continuous system, supporting life every moment through the night. Rhythm and flow remain deeply connected throughout circulation because blood movement depends upon repeating organized cycles rather than random force. Every heartbeat creates pressure waves that travel through vessels, while electrical signals coordinate muscular contraction inside the heart itself. The rhythm establishes timing, while pressure creates movement. Together, they maintain circulation throughout the body consistently. A city at night depends upon organized timing and flow. Traffic signals regulate movement through streets. Electrical systems power homes and transportation. Water systems distribute resources through hidden networks beneath the ground. If timing fails or movement becomes chaotic, the larger system quickly struggles. Inside the body, circulation follows similar principles because organization allows many connected processes to function together smoothly. Electrical activity inside the heart acts as the invisible guide coordinating each cycle. Specialized cells generate impulses automatically, while signals spread through tissue in organized sequence. Upper chambers respond first. Lower chambers contract moments later. Valves open and close according to changing pressure. Blood moves forward through carefully arranged pathways. The entire process depends upon coordination, unfolding precisely beneath the chest. Pressure then transforms this coordination into physical movement throughout the body. Contraction inside the heart raises pressure and pushes blood outward through arteries. Pressure gradually decreases through smaller vessels and capillaries, where exchange occurs between blood and tissues. Veins guide circulation back toward the heart once again. Every stage depends upon pressure differences guiding movement through connected pathways. A notable detail about circulation is how organized it remains despite enormous complexity. Trillions of cells throughout the body require oxygen, nutrients, and waste removal continuously. Yet blood usually moves through vessels reliably in ordinary life. The body maintains this organization through electrical timing, muscular contraction, vessel elasticity, pressure regulation, and ongoing communication between biological systems. The continuity of circulation is especially extraordinary because it never fully stops during life. Even during deep sleep, when muscles relax and awareness fades, blood continues moving through vessels beneath the skin. Oxygen flows toward the brain, organs, muscles, and tissues. Waste products move quietly back through circulation. Pressure waves continue spreading outward through arteries with each heartbeat beneath the darkness of the night. Scientists studying the cardiovascular system often admire how many physical and biological principles combine together inside circulation. Physics influences pressure and flow. Biology shapes muscles, vessels, and electrical activity. Chemistry supports energy production inside cells. The nervous system regulates rhythm and response. The heartbeat therefore reflects cooperation between many layers of natural processes operating simultaneously inside the body. A useful detail in circulation is how stable it can feel, even though constant movement never truly stops. Most people rarely notice blood traveling through vessels or electrical impulses spreading through heart tissue, because the system usually functions so smoothly beneath awareness. Yet every quiet moment depends upon this invisible movement continuing successfully inside the body. The organization of circulation also reflects something larger about life itself. Living systems survive through coordination and balance rather than isolated activity. The lungs depend upon circulation to distribute oxygen. The heart depends upon oxygen supplied through blood vessels. The brain depends upon steady blood flow for energy. Muscles depend upon nutrients delivered through circulation. The body functions as one connected system where rhythm and flow link everything together continuously. At rest, the heartbeat often becomes calmer and steadier because the sleeping body requires less immediate energy compared to intense physical activity. Yet even during quiet sleep, the circulation system remains active throughout the night. Electrical signals continue guiding contraction while pressure maintains blood flow through vessels. Beneath stillness, movement never truly disappears. Many people find heartbeat sounds calming because the rhythm reflects stability and continuity inside the body. Repeating patterns often feel reassuring to the nervous system because life depends upon organized cycles and dependable timing. The pulse beneath the skin quietly confirms that circulation continues supporting the body moment after moment through the darkness of rest. Humans throughout history sensed something important about the heartbeat long before understanding circulation scientifically. Ancient cultures connected the pulse to life, emotion, and vitality because the rhythm seemed deeply tied to existence itself. Modern science later revealed the extraordinary systems hidden beneath that familiar sound and movement, uncovering the electrical, muscular, and circulatory coordination supporting every beat. Deep inside your body tonight, rhythm and flow continue working together precisely. Electrical signals guide contraction, while pressure moves blood through vessels, reaching nearly every tissue. Circulation remains organized beneath the calm darkness of sleep, maintaining the endless movement supporting life itself through every quiet heartbeat of the night. Deep inside the body, circulation continues as one of the extraordinary systems found anywhere in nature. The heartbeat may sound simple when heard quietly beneath the chest, yet behind every pulse lies an immense world of coordination involving electrical activity, muscular contraction, pressure, flow, oxygen exchange, vessel regulation, and biological balance. What appears from the outside as a gentle repeating rhythm is actually the visible sign of countless interconnected processes working together continuously throughout life. The heart itself acts both as a muscular organ and as a carefully regulated timing system. Specialized cells generate electrical impulses automatically, while waves of activity spread through tissue-guiding chambers to contract in organized sequence. Pressure rises and falls with each beat, while valves direct blood forward through carefully arranged pathways. Blood vessels respond by expanding, relaxing, and regulating flow according to the changing needs of the body. Together, these systems maintain circulation through a large network extending nearly everywhere inside the body. Arteries carry blood outward from the heart, while veins guide returning circulation back once again. Tiny capillaries support exchange between blood and living tissues, where oxygen and nutrients move into cells, while waste products return towards circulation. Every organ, muscle, gland, and tissue depends upon this endless movement continuing beneath awareness. A notable truth about circulation is how completely it supports the rest of the body. The brain depends upon continuous oxygen delivery in order to think, dream, remember, and remain conscious. Muscles depend upon blood flow for movement and energy. Skin depends upon circulation for warmth and repair. Organs throughout the body rely upon the bloodstream to transport nutrients, hormones, oxygen, and many other substances required for life itself. Yet the heart also depends upon circulation in return. Coronary vessels deliver oxygen-rich blood into the heart muscle, while the organ continues pumping blood outward throughout the body. The lungs gather oxygen through breathing. Blood distributes that oxygen throughout tissues. The nervous system adjusts rhythm according to changing conditions. Every major biological system contributes to maintaining the balance required for circulation to continue. Everything remains connected through movement. Oxygen gathered in the lungs eventually reaches distant tissues through blood flow. Nutrients absorbed during digestion travel through vessels towards cells requiring energy. Hormones move through circulation carrying signals between organs. Waste products travel back toward removal systems. The bloodstream becomes the great connecting movement linking the entire body together. During exercise, the rhythm accelerates to support active muscles, requiring additional oxygen and energy. During sleep, the pulse often slows, while circulation shifts toward recovery and restoration. Emotional experiences may alter the heartbeat through signals involving the nervous system. Yet through all these changing conditions, the heart continues maintaining coordinated movement and organized flow. The body survives not because conditions remain perfectly still, but because biological systems adapt continuously while preserving balance. Pressure changes guide blood through vessels. Electrical signals coordinate timing. Vessel walls respond to flow conditions. Oxygen moves into tissues while waste products move away. The entire system remains dynamic and active every moment beneath awareness. At night, while the outside world becomes quiet and still, circulation continues beneath the surface of the sleeping body. The heartbeat sends pressure waves through arteries, while blood carries warmth and oxygen through vessels hidden beneath the skin. Inside capillary networks, exchange continues quietly between circulation and living cells. Even in sleep, the body remains filled with movement and communication. For thousands of years, humans have listened to the heartbeat with fascination because the rhythm feels deeply connected to life itself. Ancient healers sensed meaning within the pulse long before understanding electrical activity or circulation scientifically. Parents calm infants against their chest through the familiar sound of the heartbeat. Many people find repeating rhythms comforting during sleep because the body itself has always lived alongside these internal patterns. Modern science eventually uncovered the extraordinary details hidden beneath the heartbeat. The heart became understood not only as a symbol of life and emotion, but also as a highly organized biological system where electricity, muscle, pressure, and flow work together continuously. Yet even with all this knowledge, the quiet rhythm of the heartbeat still retains something deeply calming and strangely mysterious when listened to late at night. Every day, circulation travels through vast networks of vessels beneath the skin, while oxygen supports trillions of living cells throughout the body. The heartbeat continues through waking hours, movement, emotion, sleep, dreams, and quiet rest. Beneath all conscious experience, circulation remains one of the constant foundations supporting human life itself. Deep inside your chest tonight, electrical signals continue guiding the rhythm of the heart, while blood flows steadily through vessels, reaching nearly every tissue inside the body. Pressure rises and falls gently with each beat. Oxygen moves quietly into living cells. The endless movement of circulation continues beneath the calm darkness of sleep itself. Thank you for listening to the Sleepy Mind channel. I hope you enjoyed learning about the heartbeat and the quiet rhythm of circulation inside the body. Good night.